Hello, everyone.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening. Okay. So today we will discuss another important topic about current electricity, that is drift velocity. See, after this chapter, I'll start optics. Not optics, some chapters related to 11th standard also, waves. So we'll cover both ways. Dual nature and waves, I'll start. It will be for 11th also and 12th also. Both. I'll combine both topics. Okay. Fine. So next, this topic is also important, that is drift velocity. Drift velocity, like drift means like movement, how we are moving, how we are drifting, like normal ways, like normal English, general English. So what it says, when the end of conductor are connected to a two terminals of battery. Okay, so we are what is happening here, the electric field is generated or is set up. So it's moved from positive terminal to negative terminal. Movement of electrons. Now, the free electrons in a conductor experience a force. Free electrons in a conductor, but like if there is a conductor, obviously there is a free electrons, then only it can conduct. Conductor has free electrons to conduct. Insulator doesn't have, so they are non-conductors. They're called insulators. So free electrons in a conductor experience a force opposite to the direction of electric field. So to get accelerated, so they get accelerated. So acceleration of electrons, which is interrupted in solid. Like see, in solids, like they get interrupted because they are nearby. In solids, if they are like tightly packed. Instead of reading all this, I'll give you a explanation of this one. See, whenever this electron, this is our atoms or molecules in that some solid. Okay, in solid. So when electric field is passing through it, so they get charged up. This atom get charged up, or this material get this molecule get charged up. So when they get charged up, so they start oscillating. They start oscillating or vibrating, but they don't have space. So this vibration is passed on the next one. So next one also oscillate. Again, next one also oscillate. So as much as more electric field, as much as more electron pass, so this time has been reduced. This time is called relaxation time. And movement of average movement of all these molecules is called drift velocity. Average movement. And this one, they cannot move, they will not move in a like particular direction. They can move in random direction. These are like electrons. They move in random direction. These molecules in that electrons, they move in random direction. So, but they don't have space here in solid. So what will happen here? They will oscillate here in its place, and it will pass on to the next molecule. And this next molecule also oscillate, and it will pass on to next one. So actually they are tightly packed. So this vibration is passed on from one to another. So what will happen there? Oscillation. This whole thing will start oscillating. So if everyone is oscillating, everyone is vibrating, so there will be a friction. Due to that friction, you're saying that at particular temperature, it will create it will start melting or something. That is a different case, but just I'm telling you generally. It can reach to particular temperature that it starts melting, depends upon what material we are using. So due to this internal vibration of the molecules, okay, so average of all this vibration or oscillation or movement, that is called drift velocity. And time taken to strike this molecules to another, that is called relaxation time. If they are in normal, they are not electrically charged, they will not move that much fast. They will not oscillate that way. So this is also called as average relaxation time or mean relaxation time. You understood what I'm saying here? Now let's see here. Is everyone present? No. Bhanuri, Laukya, Samhita, Ajay, and Rituraj. From that, Nibeta. Okay, link is not opening. Let me check. Till then you make a note. I'll see that link is not opening. Students are saying. Can you guys hear me?
Yes, sir.
I got disconnected. Okay. So free electrons in a conductor experience a force opposite the direction of electric fields. So get accelerated. This process of acceleration is interrupted by collision with ions of a solid. So that is happening in solids. As I said before, the average time for which each electron is accelerated before collision is called mean free time. Or we can say average, you can write it as average relaxation time. I have not mentioned here, so maybe you can write that. Relaxation time. You can mention there, average relaxation time. You write this. So it is called average relaxation time. So time taken by time or time between two collision, two successive collision. That is your average relaxation time, not just ions. Okay, you can understand this, right? You can take it as molecules also, not a problem. Next here. So free electron within the metal, in addition to random motion, acquire a small velocity towards positive end of conductor. So this is called drift velocity. Okay, make a note of it. One writing.
Yes, sir.
Okay. Now, what do we see here? It's a standard formula. QE. Now, this one, let me change it. F equals to QE. Force equals to charge into electric field. Now, charge is converted, we are taking as one electron. So Q equals to NE. So N is equals to 1. So Q equals to E. That is why we have QE tau by M. Now here tau is relaxation time. Okay, I have mentioned here. Yeah, I have. Tau equals to average relaxation time. M is mass of electron. N is charge of electron. Now charge of electron is 1.6 in 10 to the power minus 19 coulomb. Don't forget to mention here minus. I haven't mentioned here. You should mention minus 1.6. Now drift velocity and electric field, they are in opposite direction. That is why we have here negative sign. So I have mentioned here also. Indicates they are in opposite direction. Come on, make a note of it. And guys, turn on your camera. Everyone. Madhusudan, Aditi, Devesh, Naukya, Samhita, Veda, Ajay. Quick. Mansun, Aditi, come on. Okay. Shall we go for next topic? mobility. Devesh, you too? Yeah. Super. Now, mobility is what? Drift velocity per unit electric field. Drift velocity per unit electric field. Now, what was drift velocity? An average velocity of all the electrons or all the particles. So average or right, average average movement of all the particles, average velocity of all the particles. That was drift velocity, and by electric field, that is your mobility, movement, how much it moves. Now, as we know, unit of velocity is what? Meter per second. Meter per second. And electric field is volt per meter. Volt per meter. Electric field is volt per meter. So because V by L, E equals to V by L. Don't forget this. Volt per meter. So we'll get meter square per volt second. Now, as we were talking about this drift velocity, so let's make some note about it. Drift velocity is very, very small, about 10 to power minus 4 meter per second. So this 10 to power minus 4 meter per second, it's actually very, very small number. If you can understand this value, it's 1 by 1, 2, 3, how many? 4. 1 by 10,000th time meter per second. So movement is very, very small. So how come we are switching it on? If you remember or if you have observed that when you're switching on your bulb, instantly it is getting on. It's not taking time. So what's the reason? Can someone tell me? The speed is so small, very small, right? 10 to power minus 4. If speed is very small, but we are switching it on and instantly it's getting on. We're switching on the bulb, it's instantly getting on. It's not taking time. Fraction of seconds getting on. So what's the reason behind that? Come on, tell me. Think and tell me, come on. What could be the possible reason? Anyone? Come on, think. You can get ideas. If you think, then only you'll get idea. Let it be wrong or right answer. Doesn't matter. Come on, think what could be the reason. See, the speed is very small. It's not taking time to switch on the bulb. Why? What do you think, Banuri? No? Okay. Ajay? What about you? No? Samhita? No? What happened? Everyone just now woke up or what? For class? Are you guys sleepy? No. Acha. Okay. What about Lokya? The reason is very, very simple. If you know, like if this is your metal or wire, whatever material, it has number of like millions of electrons, right? That n is too much high. That Q equals to NE, in that N is too high. Let it be speed be 10 to power minus 4. If we 10 to power minus 4 means 0.1231. I think so, right? 1, 2, 3, 4, correct. So this much. If I keep adding like millions of time, that means the value is increased, right? This is not just one electron. These are like millions of electrons. So number of electrons is so high. That is the reason when we are switching it on, let it be the value of drift velocity is 10 to the power minus 4, but it will get on instantly. It will not take so much time to get on. So due to number of electrons. Got it? Due to a number of electrons, the drift velocity, like it's overcome. Okay, so drift velocity is very, very small, 10 to the power minus 4, which is negligible to the thermal velocity of electron at room temperature is about 10 to the power 5 meter per second. So thermal velocity means like velocity due to heat. When we're heating some material, it starts increasing, electron starts increasing faster. So due to that, it starts melting, as I said before also. It starts melting. At particular temperature, it will start melting. Every material has their own temperatures. Okay. Okay, let's try this question. The current in a wire varies with time according to the relation, that is I equals to 4 2t square. How many coulomb of charge passes across a section of wire in a time that is t equals to 5 seconds to t equals to 10 seconds. Now, let me help you to solve this question. Then next question you will solve. Now, as we know, I equals to dq by dt. But we have here I. I is 4 plus 2t square. I is 4 plus 2t square. Now we want coulomb of charge. So for that we need charges. So q equals to, means dq equals to I dt. As you can see here also I have written. Yeah. I dt. So what we need here I dt. dq I mean to say. We want here q, charges. So this varies from 0 to q. And here 5 to 10. Time varies from 5 to 10. So here 4, lower limit 4, upper limit 10, sorry 5, upper limit 10. So we will integrate here 4 plus 2t square. Okay. If you remember integration, what shall we do in integration? How do we integration here? Come on, finish it. Finish remaining part, come on. Start doing, come on. Rituraj, are you solving? What's the answer? You know how to integrate this? Ajay, you know how to integrate? No? Okay. What about Lokya? Samhita? Okay, let's solve this then. See, whenever we are integrating, what is this? Huh. Integrating x dx. Here, everyone, learn this because this is very, very important. Integration differentiation is most important. That's why I taught in the first class of 11th standard. Okay, limits are 0 to some say 5. Okay, so this, what is the formula here? So x to power n plus 1 divided by n plus 1. X to power n plus 1 divided by n plus 1. So now we have here 4 integration of plus 2t square 5 to 10. So whatever limit it is, let it be. Now 4 integration of 4 will be 4t because here t to the power 0. T to power 0 means equals to 1. 0 equals to 1. So here we have 1. So 1 instead of 1 we have replaced with t to power 0 plus 2t cube by 3. See everyone, you can write those later. Limit, upper limit minus lower limit. So upper limit will substitute in place of this one and subtract this one. Like this. Come on, make a note of it. Then substitute this 10 in place of t and 5 in place of t and subtract it. Come on, finish it. Finish the calculation part. Madhusudan, are you writing?
Yes, sir.
Okay. Turn on the camera. Samhita, done writing? Okay. What about Veda? Do your calculation by yourself. Don't just copy calculation also.
Excuse me, sir.
Yeah.
Sorry for the disturbance. This is the admin speaking. Please ask the children to on their cameras, sir. All the children.
Some has turned on camera, but some hasn't.
Children, please all of you turn on your cameras. Sorry for the disturbance. Thank you, sir. Please carry on.
Yeah, no. Done, everyone? Cool. Okay then. Let's go for next question. Try this one. The below. If the charge flowing through a conductor is given by Q equals to 1.5 T square plus T, the current cause in 2 seconds will be what? Try this question. Previous question also will do, but let's go by little bit toughness. This is easier. We'll do first easier.
Sir,
Yeah.
is it 10 ampere?
7 ampere here.
Okay.
Because we have to differentiate. Here we have Q. We already have Q. We don't have I. That question was a little bit different. What we did there, where is it? It was I given and we need to find Q. How many coulomb? Here we have Q. Q equals to 1.5 T square plus T. So we'll differentiate here. How to differentiate dq by dt? So differentiate it, remember like that, differentiation means decreasing. Integration means increasing. So here it will be 1.2 into 1.5 T plus 1, like that. So it will be 3T plus 1. That will be a final differentiation form. So then we will substitute the value T equals to 2. That's it.
So how do we know when to integrate and how do we know when to differentiate in the question?
Now, yeah, see what is given here. If the charge flowing through a conductor is given by, so charge is given, find the current. So I equals to dq by dt. Now, once again, see next previous question. What was that? Current in a wire is given by I equals to something, blah, blah, blah. Current in a wire is given. And they asked us to find how many coulomb of charge. So they asked us to find charge. That is why we integrated there. So this is the difference between these two questions. Clear? Okay. So T equals to 2. So we substitute here 2 here, plus 1. So you get 7 ampere. Okay? Okay, done everyone? Ajay? Done?
1 second, sir.
Yeah, okay.
I'm done.
Okay. What about others? Laukya, done? Okay. Rituraj, Madhusudan?
Done, sir. Done, sir.
ठीक है. What about Veda? Okay. Okay, guys. Then let's do some numericals tomorrow. We'll see you tomorrow. Okay. Bye-bye, everyone.